Okay, so I want to walk through some examples of finding focal points. And I have up here, c squared, which is, well, c is the distance from the center of your ellipse to the focus, is equal to a squared minus b squared, where a and b would be the lengths of, at least half the major and the minor axes. If 2a is the whole axis and 2b is the whole axis for the minor axes. Okay, so this first example, obviously I want to put it into standard form, so I want to get a 1. So I'm going to divide everything by 16, just so I can figure out what my a squared and b squared values are. So this becomes x squared over 1 plus y squared over 16 equals 1. And once you do that, again, now we can identify, okay, this is my a squared value because it's the larger of the two numbers. This is my b squared value because it's the smaller of the two numbers. So if I had to graph this, I know the square root of 16 is 4. So my major axis would be 2 4s, and my minor axis would be the square root of 1, which is 1, so it's 2 1s, or 2. But all I'm looking for is the coordinates of the focus. And so I can find my c squared value by, again, doing c squared equals a squared minus b squared. So it would be 16 minus 1, which equals 15. So my c is equal to plus or minus root 15. And we're introducing the square root again, so we want the plus minus, but I also like the geometric point of view because plus minus means I'm going on both sides of the center of this ellipse. Now, the center is 0, 0. So I know, and it doesn't ask me to sketch this, but I know the center is 0, 0, and it's opening more in the vertical direction, right? So that's going to help me identify where I'm deviating from the center for this root 15. So since the major axis is in the y direction, right, the larger number, I'm going to go from the center, I'm going to go up root 15 and down root 15. So the coordinates of the focus, of the focal points will be there and there. And this distance right here is root 15. This distance right there is root 15. So I'm starting at the center, going up root 15 and down root 15. So I might want to, I could, like I know that the x-coordinate of each of those points is 0. So a little bit thinner here. So 0, but then from that I'm going up root 15 and down root 15. So I could put them together as just like one ordered pair put together. Okay, so that would be the two focal points. For example B, notice it's already in standard form. Notice it's already a 1. This is a larger value, so in the x direction, my ellipse is opening in that direction, and the y value is a little bit smaller. Again, if I draw a sketch of this, just to kind of make sure I know where this ellipse is centered, it's at negative 9, 7. So negative 9, 7. And from that, like I would go out 5 in this direction, out 5 in this direction, down 3, down 3. So here's my, again, just a sketch of the ellipse. And why is that important? Well, I want to make sure, try to grab that guy right there, a little more centered, because I want to know the focal points. The focal points, just from a geometric point of view, have to run along the major axes. So in this case, it's in the x direction. Okay, so let's go ahead and find those distances, or that distance, I should say. So c squared equals a squared minus b squared. Okay, larger minus smaller, so that's why I'd like to think about it, because it does not matter where this a squared is, because again, it depends on the direction of your ellipse. So c squared is equal to 16. C is equal to plus or minus 4. And again, that means from the center, I'm going both left and right 4 units. Okay, so I really like that plus or minus 4. So what was the center? The center was originally negative 9, 7. So negative 9, 7, that's your center. So we're going to go from that center 4 units in either direction. So negative 9, and I can think of like plus or minus 4, right? And then comma 7. So I'm going 4 units from the x-coordinate. Notice in the other one I was going, you can still see it, I was going in the y-coordinate because it was open in that direction. So negative 9 plus or minus 4. So then one of the coordinates could be negative 5, 7. One of the coordinates would be negative 13, 7. Okay? Before you see the video for part C, try it on your own and then check the video, see if you get the right answer. So pause it, ready? Pause. Right. Okay, so this one, again, so the center's at -2, -1, might be helpful to kind of see, -2, -1, and it's opening in the the vertical direction because 10 is bigger than 4. So again, I don't know, I just, kind of a sketch here. And so the center here is -2, -1. And then define your c squared value would be a squared minus b squared, which is 10 minus 4, which is 6. So c is plus or minus the square root of 6. So I'm going to deviate root 6, and again in the y direction. And it's the y direction because this value is larger, right? So that determines my major axes. So from -2, -1, I'm going to go a plus or minus root 6 in the y direction. And I can't really simplify -1 plus or minus root 6, so I'm actually just going to leave it just like this. I'm perfectly fine with the symmetry of the, of writing that as like one order pair that represents two numbers. Okay, now we could also find focal points from a graph. So I just have to interpret like what the major and the minor axes are. So if I think about trying to say, okay, well the center line here is the minor axis, the center line here is the major axis, and then we just count. So my a squared value is 1, 2, 3, 4, 5. So a is 5, which means a squared is 25. And then my b value, 1, 2, 3. So my b squared value is 9. Oh, that seems like it's awfully familiar, no? Right? Wait, which example? All right, there, 25 and 9. So to get c squared, again, I could do c squared equals a squared minus b squared. C squared equals 16. C equals plus or minus 4. And so then I'm going to go plus or minus 4 from the center. And I'm going in the y direction. So actually, that's kind of nice. 1, 2, 3, 4. There it is. 1, 2, 3, 4. And there it is. Okay. So from these, so these 2 points. So again, I could have thought about it as -1, 2, 3, 1. -3, 1 is my center, and I'm going to go plus or minus 4. -3, 1 plus or minus 4, because I'm going in the y direction. And then I could actually label those points. -3, 5, -3, -3, which I had right there. Cool. Here's one more, example B. This time, again, it was more in the horizontal direction. So let's see, if this would be the major axes, and the minor axes would be here. So it looks like my a value, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my a squared would be 100. And then in my b value, 1, 2, 3, 4. So b squared, oh, that's fun, is 16. So then I subtract the 2. My c squared value, so c squared is equal to 100 minus 16, which is 84. So c would equal plus or minus root 84. Square root of 84 has a 4 in it. It's 4 times 21. So we could say that is equal to plus or minus 2 root 21. So that's the distance I'm going to deviate from the center to get to my 2 focal points. And again, it's in the x direction because that's the major axis. So I'm going to go that direction and that direction, this distance of 2 root 21. Well, root 81 would have been 9. So actually, that's even closer to, like a little bit closer to there if I really want to draw an accurate graph. And you'll find out that the more stretched, right, that your ellipse is, that the further the focal points are to the endpoints of the major axes. And if you make it more circular, those focal points come in until they become just one point, which is the center of just a circle. Okay, so what was our center here? It was 1, 2, 3, 4, 5, 6, 7, 1, 2. So my center was 7, 2, and then I'm going to deviate plus or minus 2 root 21 here from the x. So I could say 7 plus or minus 2 root 21, comma, 2. All right. And I mean, you can't help but think about this as being like an answer to a quadratic, which is true, that plus or minus, because you're going in, both directions. Okay, so that's that.